Hello everybody, welcome to another stream. Apparently there's a new Stone Rebel album, so yay. This way releases these like every 2 weeks or every month. It's crazy. So, last stream we started on this debug rendering set functions. So we can draw these debug shapes from CPU and GPU code very easily and be able to tell what the hell our variables mean. And this would be super helpful to finish the problem. Yeah, to finish a set of problems we're trying to deal with in the LOD rendering code. So as you can tell, I've already got this access line bounding box and view space working. So we can tell that this is not the problem. I want to kind of improve this code this stream, but we're going to probably start on something else because we spent last stream doing that. So one thing that you can see is the box has a back, right? But it actually goes behind those spheres, and those spheres are glitching out purely because I need to fix the bug. I don't know what the bug is yet, so I need these debug shapes to help me. So it's another problem. It's not to do with this box, that's what we can tell. But can you see these the back lines of the box? They're behind there, but they're drawing in front of this shape, and that's because we don't check to see if what would. So this so these spheres get drawn first, and then in a separate ray tracing path, this box gets drawn. So the problem is we're not checking the depth buffer to see, oh, how far is that stuff in the scene being rendered? And we're not sort of saying, well, if the box is behind that stuff, then don't render it. So we should probably add some code like that, because I'm sure this will get quite annoying in some cases when we want to debug. So we need to have an option to use to basically Z test or depth test. And we don't even have a depth buffer yet, so we'll have to put one of those in because we do all in compute, so just be a texture. We'll just do floating point for now because it's easier, but we'll make functions so we can change it later. So where we're starting is in the right. First of all, I want to comment out some of this code. We'll do the OBB later, the oriented bounding box. We'll do that later. So what we're going to do is go to these draw 3D whatever functions, and we need to add another bit for Z test. On all of the 3D ones. Oh, wrong one. It's in shared, isn't it? There's a share between. Oh no. Oh yeah. Cool. Right, so just plop those all in there. Right at the end. Lovely Boolean. Saving Z test, but only for the 3D ones, right? Because the 2D ones don't make sense, they're in screen space. That'd be cool. So now we need to actually put that in the functions. So we're going to pass it into this alloc words always. And the reason is because then we don't have to worry about how to get it into the array of words. Alright, so that's all in there now. So we've added this Z test thing. So that's not in a header file, is it? It's all good. So with this one, we just want to make sure that we pack it probably into the high bit. So I think we'll just do a sort of Z test 31 and then OR these two together. So in the high bit, here, 31, that represents whether or not we want a Z test. The 15 bits, oh, for crying out loud, what do I do? Take one. Oh, okay. Why don't you take one? I'm a melon. Oh, no, that one worked. Yeah, then shift left 16. Right. These bits all represent the count. So how many words are in the... so you essentially read the header, the first word, and in the low bits, in these low bits is an enum to say what shape type it is. In these bits here, it's to say how many words until you get to the next header. And then that top bit is going to be if we Z test or not against the depth buffer within the scene. So we don't draw our debug shapes all over the scene and get it in the way. So that's really nice. We just got to add that now to the shader code, the GPU version. This is the CPU version. See, it works with pointers. We get pointer back. Now we've got GPU version which works with indices. So that is in, I think it's in, okay, there you go, somewhere around here. Here we go. So we're going to add that Boolean Z test. And we're going to do the same thing for all of these functions again, right? All the 3D ones, remember? Okay, so again, we're going to add the Z test thing in here. And then here. And then after this, we can make a depth buffer, add it to our ray tracer, and then we can read out the value in the debug draw ray tracer, which is separate from the sphere ray tracer. Excuse me. So it'll be a Z test shift left 31, board with that, and so that should be, oh, something's not compiling. Z test true. Hey Toggle, how's it going? Awesome. What you working on? It's been a while. How you been? Alright, here's the OOB. We're just gonna comment that out. I've had a thought off stream. I think I know how I can do the OOB, but I want to do it last because I know I can do the other ones. So I want to just make a bit of progress before I do that one. Right. So as you can tell, this at the back is not Z testing against the spheres in the middle of this box. So we need to create a depth buffer. Because we're doing it all manually, we yeah, because we're doing it manually, we're just going to create texture, and we'll just sort of, it'll be a float 32 texture. Float 32 is like overkill for a depth buffer, but anything other than that is an optimization, and I would rather not sort of deal with that right now. Still working on TUI, getting close to being done. Awesome. I know what you mean. It's like, yeah, getting close. Yeah, doing a compiler, you're just sort of so close, and you just but then something about it where you're like, oh, hang on a minute, this could be better, you know, because you write more usage code and you're like, oh yeah, or more examples. They just do some more tweaking. But yeah, it's awesome. Have you got any? I'm guessing like a lot of your like, have you got any sort of like for your things that you display in stream? Do you use that TUI thing you've made for that? All those like things you have on in your stream, the widgets and such. Yes, we're just gonna make a new texture. This is not gonna be an order depth. You know, we should call it depth texture and just break tradition. You know what I mean? I don't know why. Yeah. Anyway, depth texture. It's the depth texture. Texture 2D. Oh, what format is it? Good point. I haven't really got a. I have F32 float. Past Henry is on it. So that's it. Oh, sample type. Are we going to be sampling from this? I don't think so. It's just storing. We might sample. Let's not do support sampling for now. Resolution. Good point. Well, I've got hard-coded width and height for now, so hard-coded it is. No MIP levels and no erase slices. Rightio. So we're creating that texture now. So now we just got to use it. So we have a tiled ray tracer. Sphere tiled ray tracer, this boy. This one likes to render pixels to the screen. So we want to be able to essentially write our output to this, to this. So essentially we're going to go into, so we should probably clear our texture as well actually. I just remembered. GGFX depth texture. Yes. Then you want to be able to sync as write only on that one with a depth texture. Okay. So we've got to clear it still. And I think I have a function for that. Past me, I think, has solved this problem. Shoot. Right, I don't know where I'll stick it. I can stick it. Well, I can stick it just for the ray tracer. G command texture clear. Okay. So the clear value is going to be 0. Is that a good idea? I don't know. Wait, do we need to clear it? No, because we're doing a full screen pass. So the shader itself is going to just write out the final thing to it. This is a forward renderer, it just writes out the final pixel. Not quite there yet. I almost done with it and then broke it into pieces again. Yeah. Yes, many times I've done similar. Fair play. That's cool though, you're nearly there though. You got this. Hey VMT, whoop whoop. Been awesome, it's been around on Twitch, juicy schedule, so you get back into this, sweet. How goes it? It go good. Is that good? Das is good. We have an LOD system that this is LOD 0. This is the first level of detail, and it's not even like the proper one either. I've just said, hey, every sphere exists in this level of detail just to debug something. And I was going to go into the lower ones, but then a bug happened. So we're just working on debug rendering shapes, like this lovely axis line banner box you see around it. So right now we've got Wait a minute, my mouse is being captured by my window. Eh. So right now we've got an LOD system where you got a cluster which is a 4x4x4 set of spheres. And the clusters fill a 2, 5, 6 cubed space of spheres, right? And then so that's the highest level of detail, which is like 6 or something. And then all of the level of details that come that are lower than that are essentially in a yeah, you build like a cluster tree. So you take like a so you take a 2x2x2 set of clusters and you produce a lower cluster from that. Yeah, a lower level detail cluster, which has 1 sphere for every 2 spheres. Yeah, so we've got this system built, but it's just not fully rendering yet. So we're trying to debug that, and we don't really have good debugging tools. So we're sort of just building that now, effectively. Yeah, so it's going good. I just yeah, so we're gonna be working on basically like improving this LOD system, or fiddling about and trying to see like, hey, what looks nice, give it some color, materials maybe, give it do some animation perhaps, make some static and dynamic models. But yeah, that's about it. Yeah, I think the base shape we should be seeing inside the volume is we have an edit down which puts a sphere down, and this thing gets filled with spheres. So the compression is basically you store the history of what it takes to make it with a bunch of brush strokes in a sense. And this thing should be filled with spheres. So LOD0 should have maybe like a few big guys in the middle, maybe, or maybe not. Is it no Z buffer here? Or why does it look so disorientating? Yeah, exactly. This is what we're adding right now is a Z buffer so we can do some Z testing in this debug. Optional Z testing. Because you might want to have your debug stuff draw on top no matter what. So, yeah. We're literally just placing that in now. Because I haven't had a depth buffer because I haven't needed one yet. Because we've only been doing a single pass draw in 3D. But this is our second pass. And it draws after the sphere ray tracer. So now that's bounded, what we can now do is write the single depth in there. So closest hit depth, that one is our depth in view space. So that's what we're just going to throw into the texture, and we're just going to say it's depth in view space. So we found a hit. Well, I think always we'll store something, no matter what. So we'll say, okay. First of all, we have to do the good old flipperoo. And we'll say store texture BC depth texture ucoord, and there we go. So if we run that, it's either going to blow up the computer or it's going to work. Right, so the stream dies, it's AMD's fault. There we go. Alright, we're still here. So if we open that up in RenderDoc, did I get a RenderDoc installed? I think I did. Yeah, how's work been with you, VMT? How's life been? So if I do a capture, we should be able to just debug the texture. It's somewhere in here. There you go. Is that it? No, 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 no. No, that's my color. It just looks weird because I just encode it as a 32-bit integer. So I don't think it can read it. What is our texture? Does it tell me? It should have the debug name. Oh, depth texture. Let's look at that one. Right, let's go past here. The value is just 0 the whole time. Oh yeah, we didn't need it clear. What image is that one? Image what? What's the number? Two five eight, I guess. I should be seeing stuff here. I'm not seeing it though. I don't know what I did. Pretty sure I compiled it. Yeah, I don't know why. I don't need to do the clear. I'm doing a full screen right. So it just kept that there, unfortunately. I think I had some bugs in RenderDoc at some point where it wasn't showing me the correct result of an image. But then I read it back and used my print code, and it was actually showing the right results. So maybe I've got such a weird setup that I've got bugs in RenderDoc happening. Life has been good. This Windows program stuff I've been doing for the past few weeks is unoptimal, but I'm learning something at least. Fair play. Yeah, I remember doing like WPF. So if it's anything like that, yeah, I think I'm kind of understand. Like this whole XAML thing was still WPF. Yeah. So did I read you right? The The LOD levels aren't working because of some bug. They're basically implemented but not rendered yet. Yeah. So basically, I've just implemented them and I'm trying to get them up and running. Yeah. So I've just implemented like a big body of code, and that sort of generates this LOD tree from a bunch of like paint operations. And I've sort of done all the printing. It's like, oh, that's good. Fixed up the bits where it wasn't working. And now I'm trying to actually do the ray tracer for it and get it all plugged in. It should be working, but yeah, there's a bug in the and I think the ray tracing. But yeah. So that was terrible. Yes, it's very there's a lot of stuff you have to write to get it, and it's also strangely limited as well. Very strange, like thing that got made. So where's this depth texture? This is not, that's the color texture. It's because of it's not reading it back as a anyway. What is that though? That 1 by 1. Do we have a 1 by 1? See, what's weird as well is it displays the color in that thumbnail just fine. The view treated as a okay, it's because it's reading the view, but if you read the raw contents, no. Anyway, what was I looking at? I was looking at the I'm trying to find the depth texture. I think this is a 1 by 1. No. What is that one? That's not the depth texture. Where is it? It should be in here. Image. They're debug names, right? Or texture they're called, right? Or image. Boom. View. Undefined, undefined. Undefined, and still undefined. I don't know if there's trust render doc. Should we just yeah, I don't know whether it's trusted or not. Am I in the right one? I must be. There's another version of Yeah, this is the right version. Oh, what is this? Is this the wrong code? No, it's only one version of this shader. Okay. Should be storing them. So it probably is. And how we can tell that is we'll be doing another rage. We're doing the debug render. So this guy is going to take in that, and we'll just simply draw it to the screen and view it. So read only depth texture. We'll just poke that in there. Rightio. So in this 3D debug render thing, we'll essentially just at the end, we'll do a store. No matter what, we'll do a store. Excellent. And the store is going to yeah, stored in the right one. We'll do a load of that pixel coordinate, and that'll give me a float back. And I think, oh, we're gonna pack it. It might show up in a bit of, no, it should be fine. You're ready, right? How's CodeXL compared to, say, Nsight? I've not tried CodeXL. I know they've got a new one called AMD Reshape, right? They just released this recently. I didn't know this one existed. GPU debugger, CPU profiler, or GPU profiler. Interesting. And this one is... Right, I've never seen this one. I wonder how it is on Linux. Because I tried downloading another Linux AMD client, and that one showed up, like all the background was white and the font was white, and it just didn't go with the theme. So unfortunately, I couldn't really use it without faffing. No longer being actually developed or supported. There's a race for archived. Right. That's not great. So I guess this is... So what's this one then? At the instruction level, validation, and... So I guess this is more like a shader debugger. Maybe. Infinite loops, experimental. Yeah, the infinite loops in the whole driver anyway are experimental. On Linux, it'll bring down your whole desktop, so... Yeah. But yeah, I've never tried the other one, or this one. But I saw this one recently. Yet to try these tools out. When I got some more serious shaders and that to optimize a lot, I'm probably going to look more into these. But I think I did it by hand by looking at the assembled output last time, wasn't it? Hey, soft phone. Oh. Yeah, I forgot what one I downloaded on Linux. I forget now. Maybe there's another tool or something. Alright, so see if this explodes in my face. Here we go. Right, so I'm not seeing the depth texture show up anything. For some reason. We can say, hey, if anything is not like... So this is a floating point back, right? So if you say is not is inf. So it'd be white if it's not infinite. My face. So apparently the whole thing's like 0 or something. Right? Is it just 0? My face. Right, so it's clearly just all 0. Why? Didn't we? I swear we just stored in there. Is it like an early out? Oh, it's not the sphere ray tracer tiled, is it? You bugger. It's called a different one. I think it's a different one. No, it is this one. It is this one, isn't it? I think so. That's the BVH ray tracer. Yeah. I think this is it then. So why is it not writing the thing at the end? There's a return. Oh no, that's only for the dead code. Found here. Yeah. Why? Okay, we're going to undo this thing here. And what we're going to do is we're going to just simply poke at this to see if we, like, let's reverse this. Let's not do this BGR thing, and it should, the ball should show up in a sort of a different color. Yes, it should show up in like a different color now. So that means that this is the code that gets ran. Closest hit depth. I could have swore. Alright, so some printing. I'm a bit confused. Is it trying to store it out as an integer or something like that, and then taking a small value to like a... Right, so it's got a bunch of inf. So what about when it's not infinite? So it's always inf. Always. Right, now we're seeing stuff. Values. Okay. So these values should be put on the screen. Texture. Sorry, on the depth texture. So if I just literally move backwards. Okay, nothing happened there. Am I reading that as an integer? Damn it, I'm reading that as an integer. Oh, okay. Right, we found the problem. So that's good. So I was reading it as an integer when we we're trying to debug it here. That was the problem. So now we run this. I should be seeing something. Let's just not as inf again. So it must be reading a float back, right? So let's do like a if r. Well, let's just do a print. It's only a float, but we sort of put it into a float 4, just do every pixel. Maybe the alpha is just too... God. Why is it a bunch of zeros? What did I do? Oh, hang on a minute. Did I not instantiate it correctly? my GPU API. See what I did. Storage format none, sample format yes. Shoot. That's probably why it wasn't showing up. I got these parameters the wrong way around. So it's only expecting to be sampled. So we're not getting a descriptor in the descriptor set, so it's not doing anything. For crying out loud. Right, I've learned my mistake there now. Okay, so now when we run it, we're going to see stuff on screen. Right, we're seeing inf in some places. Not is inf. So we should see black if it's inf. There we go. Depth. So it's only showing white because I'm saying, hey, if it's infinite, show black. If it's not infinite, show white. But that's all we need to know. We have something in there. So we should be able to view it in render doc actually. If I was to delete this, build up render doc, I want to see if this tool still works for me. And it just wasn't because I did a complicated set of compute shaders. So we'll do a capture here. And then close that, load that one up. What is it? This one. Texture viewer. Depth texture apparently. So there's a range of value. Where is it? Inf and yeah. So this one, if I set it to like 200, you're starting to see something, yeah? So I set it to 400. So we're seeing, really seeing some values. Yeah, I think, but yeah. You can add like things into render doc to view your custom textures, I think. But there's nothing to worry about too much for now. Because we'll probably change that format in the future anyway. Okay. So let's get using this depth texture then. So how are we going to use it? Well, we need to load the depth. So obviously each thread gets a pixel. So for every pixel, we're just going to pull in the depth value from the scene. So we're just going to say scene depth, like that, okay? Now, let's get you coordinate. Kind of want to flip it there, okay. So read that in. Now we've got our scene depth. So what are we putting at the start of this stream? In the first word, so in the header, there is 3 bits of information. The first 16 bits have the type. For some reason we use 16 bits, but there you go. The next 15 bits now are the word count. The final, this will be 7. The final one is z-test. So this one will say, hey, we want to z-test the shape because I don't want it to get in the way of the actual scene. Whereas sometimes you want to have a debug shape that just goes over everything in the scene because it's just so busy. Just depends on the thing you want to view. So this one is going to pick the final bit. So we just shift right 31, and that will get us the z-test boolean. So now what we want to do is have a every time we iterate over a new shape to try and draw and ray trace against it, This Z test is going to be different. Yeah, so the value we're testing against. Sorry, so we do our ray trace, then we say if our hit, so if we hit and if our hit is closer than the closest hit depth, then we can update the depth. We want this to also include the scene depth from the scene if only Z test is true. So what we want to say is like, what is our test depth, I guess we can call it. So if Z test is true, then we need to do a min between scene depth and closest hit depth. If it's not true, then it's just closest hit depth, right? And then this is the value we're going to test against for this thing here. So if we try that now, what we should get is this ABB, because we set true in our draw 3D ABB. So this is in the shader. So we can have as many threads as we want. Just say, hey, draw this ABB for us. So we give that a run now. And there we go, look at that, it's Z tested. So now, these spheres don't get overwritten by this debug shape which is drawn afterwards on the screen. So if I was to flip this switch to false here, what we'll see is the lines go over the spheres at the back, which they shouldn't do in some cases, right? Cool. So now we've got our software depth buffer in place. That'd be pretty nice to work with. Yeah. Software depth buffer as well. No hardware depth buffer. Just write pixel out to texture, read pixel from texture. That's all you need. So the next thing we're going to do is we're going to take some shapes from Inigo Quilez, as every programmer does out there. And we're going to build a couple more ones. So sphere, be a nice and easy one to debug some points in space. And the other one is going to be, we're going to probably take the capsule and probably the capped cone. And we're going to do a nice vector debug thing as well. So, first of all, I haven't really got, we should do I need to have a place where we sort of dump any sort of like, I think in my docs folder, we'll make one called like attribution or something like that, right? Because it's hard to keep track of this stuff. It's easy to forget it basically. If you add a piece of code to your repo and you forget like, oh, I took it from here, you should really keep note of where you take code that is licensed, or someone who you just want to say thank you to anyway. This code is actually under the MIT license. And so yeah, I should probably keep track of that. If you go to his site, it does say it somewhere. Yeah, here you go. All my code snippets are on MIT. So we should obey. So we'll probably want to say, first of all, check all, so number one, all libraries inside the depths folder, right? Or directory. That's number one. Number two, so I guess we'll just list them all out. So, Quilez. So this is for the, I guess we might like put for the ray traced, so MIT license, right? So for specifically right now, we'll probably use the SDF shapes, and another one is for ray trace intersection. Right. So there we go. So we don't want to lose track of that. So we can always put that in later, whenever it matters. Okay, so we probably. So what does this one do here? Ray origin, ray direction, CE. I guess that's the center of the sphere, like a position. Yeah. It was interesting as we looked at it in the yeah. And this the radius. This comment. Oh yeah. But one bit confused is because this box one that we looked at last time, it piggybacks off the fact that it is centered around the origin. So the box is at origin 0, 0. Which I'm gonna probably take this one because I think our one's a bit messed on with the way I calculated the normal was a bit off. So I want to try this one out later. Again. But yeah, let's just. I think I've already got one of these actually. But yeah. I think I've already got a sphere versus ray. Maybe it was from the same place. It might be inlined. What did pass me do? Right, sphere versus ray, and I think it was just from another one. And then we do this close hit for anti-aliasing detection. Yes, a bit of a different one. So I do have this. It's got T and T max on it as well. Yeah, normal on it as well. Oh. And then I guess this tells you to make it normal. Alternative method, compute H. Yeah, we'll just use R1, I think. Okay, where does pass me do this? Sphere? Right. So I need to make the sphere strut, apparently. Center position, radius, color. I don't know why I got color in there, but I got color in there. Yeah. Okay, so we've already got ray origin, ray direction, T min, 0, T max, infinite. We'll chuck an S in this, S, center position. So I've got to pull these out the words buffer. So what does it look like with the sphere in view space? Right, so it's position X, Y, Z, and then radius. Right, so let's pull those 32-bit words out. Flow 32 times 3. Excuse me. So pull out those words. Yep, and then want to set the radius. Which is in number 4. I will do the bit convert from integer to reinterpret cast into a float from ints. So is the radius. Cool. So I guess we'll do the whole hit code as well. This one here though. I need to change that to test depth. Oh, is the colors in there as well, isn't it? Oh yeah, of course it is. So the color is just 5. Color 5. No bit conversion though because we want it as an integer. Right. So we unpack that, chuck it in there, and get the normal out as well. Excellent. So that should be the sphere one. So we're going to test that out. Let's go to our draw 3D AABB. So this is where we do it inside the where we do the LOD selection code, I think. So I want to do a sphere, which is going to probably be as big as the box. So we need to pass in a center position. So it'd be the center of in view space. Oh, sphere in view space. And then we want to do a sort of half extent, probably along the X. Should be good enough. As a radius. What's the rest of the parameters? No help available. Then color. Then Z test or not. There we go. So let's try that one up. Oh. Oh, it's called insert index. Right, word index. So that's obviously been copied from the code that sort of puts it in the buffer. Oh. Okay. So we should be seeing a sphere in here somewhere, but I see no sphere. So the next thing to check is like, well, we have only tested rendering one shape at the moment. So perhaps it's not allowing us to do multiple shapes. Okay, so there is the debug sphere. And it is not being Z tested, which is, as you can see. But if we enable Z test, so I guess our debugging drawer doesn't. I guess it's being Z tested now. Yes, it is. But yeah, I guess our drawing code doesn't support multiple shapes. So I'll do the sphere first. Oh, it's picking up as 2 spheres. So something is wrong with the... So I've said, hey, there's 6 words. So let's look at the render code. So it's putting in the 6 words, right? So you got the count, it's set to this max, comes in. It definitely iterates twice. Words 0. That's the problem. We're only reading from the first. That's been the issue. Okay. So that should be multiple there. And there we go, 2 shapes. And they're being Z tested, look at that. So they will Z test with each other automatically. So that's 2 debug shapes. So the next one is going to be like super helpful. Like that one is already quite helpful. You can just put a sphere somewhere, represents a point in space. And notice we have got a bit of like shading. So there is, you can tell there's like some form of like light calculation in some sense. But we make it so there's like, we make it so there's a light coming from one direction in world space, but we make it apply from kind of both directions at the moment. So one side doesn't get dark. And we don't fully take it off either. So we just give it so it's just not, it's got some kind of different shading on each side or something. Or the neighboring sides at least. So the next one is the vector one, right? Well, we can try the sphere in world space just for a moment. So we have a sphere in world space, and that essentially does the same as the view space one, but it will just basically transform the position. Now I didn't transform the radius. So I think maybe something like that is probably a good idea. So we can test that out just quick. Draw sphere. World space. This time we'll put it at, let's say 0. 0 that. And then we'll do like maybe like a 5. Okay, so there is in world space. And that's 5 big apparently. So it's yeah. Sure. I guess if I make that 10, it should just be twice the size. There you go. Cool. So that's nice. So if we now do something else, which is the vector one. This one is going to be extremely useful. I just realized I didn't change the thickness. Right, so this OBB, what is that one? View from local. Oh, and I didn't change this is the CPU code. Oh crap. I need to change in the GPU code as well. Oh no, I changed the GPU code. Yes, radius. Okay. Right. So the next thing to change is the OBB. It's got this like border thickness. Like we're just gonna say, so view from local. I guess we'll just say this is in the local space of the object. So I should probably write that. So we don't get confused. Bit long, but it's the price you pay for things to be easy to understand without digging through source code. Alright, so because it's in local space, we don't really have move it, I think. So the other one to look at is this vector view space. Automatically, you know that's view space, view space, view space. So I don't have to document that. So when you're transforming the world space one, this does have to be multiply the vector. It's not a vector. Right, thickness of the vector. And again, I think we'll do the whole length trick. We just expand out to a vector 3. Yeah. So we'll just take that and chuck that in the here. So how we're going to debug draw this vector? So obviously we're doing ray tracing, right? It's how the rest of the implementation works. So, but what are we going to comprise? What the what? Yeah. What the what? Oh, did I close too many of my things? No. Oh. Oops. Just correct the CP code now. Alright. So, how I want to render this vector is I probably just want, I want to make it look kind of nice. I don't want to make it look crap. So we're probably going to use a capsule for the base. For like the point, for the, just to, represent the line part. So it's a little bit rounded. Then I want to use probably this capped code. So you can, there's this sort of cap code here that you can see. So maybe we can sort of play around with that to make it better, but maybe it's already got variables, so we'll look into that as well. There's a shader toy example. Let's take a look. It's even got it like textured as well in a sense. Nice. Nice. So let's do that. I like the idea of that. So beautiful. Let's take that. And above our ray tracer, we are simply going to dump this code. And let's go for ham and get it into C instead of GLSL. In variables. What else must they be? I think in means like it takes them via a reference. But yeah, not sure what that's like in shader code because it always gets inlined anyway. Maybe make some read-only as well. So these vec3s get replaced into our sort of vec3 notation. Meaning this is like a sub. And then a dot product. Get that right. There you go. These are what exactly? A couple of floats. Cool. Let's get the F32s in there. I like me some F32s. Let's clear up this. Make it nicer. Don't have doubles in shaders. You have to enable that, and I've got it disabled for now. Just got to figure out these all floats. Oh, I don't know if I can get a normal with this. Yeah, I wonder if we can figure out to get a normal. Because essentially it's like a projected sphere. I looked into, wait, what did I do with the capsule initially? Was it a... I think I did a capsule versus capsule collision test before. And I nearly got it working. I think there's one really weird edge case that it would fall apart, but it was kind of okay. Everything else. What are we trying to sort out? Should we factor all that? Oh, let's get rid of this horrible shorthand thing. Okay, so some of these use various operators. Sub. Right. Okay. This is a... So we're squaring a float. Good, good, good. Oh, float 32, please. There floats, float, float. Right, so that returns you t. So t is obviously the distance you travel on the ray until you hit the capsule. So to calculate a normal for that, I wonder if there's one dotted about somewhere. In the code. Cap normal. Sweet. I want that. So thank you very much. So if we got a hit, we need that. Okay, so A, B, R. Cool. So we need to make a new strut. This strut is going to be... Maybe I should do all my ray hits with the same strut. Ray versus sphere hit. Did hit. Oh yeah, but that one needed a different one. Right, let's just do a capsule versus ray hit. It's a success T, and then a normal. Capsule versus ray. Ray 3D, I guess. So with this one, let's bring that into the vector. Debug draw. Oh, I completely didn't just put that in there and complete all the bells and whistles, did I? So here we'll just sort of make a hit thing. We'll do hit. Yeah, we could probably just encode it in like the t value or something, you know, as infinite or whatever, or negative, whatever. But for now, we're just gonna do one of these. So you always return here. This will mean hit.success is equal to true. Yeah, 2 seconds, just gotta text my wife back. Okay. Nope. What happened to my chat now? There we go. So do hit equal true. Then this calculates the normal. So hit dot normal equal that, and this is the hit dot t. So just want to get that right. So it's the dot of those two. Yep. That and that. Clamp float. Rightio, so does that compile? Returning T here, body caps. Interesting. Let's hit the cap here. Right, so I guess we just say, crying out loud, else body caps then we need to move this out and say if hit dot success. Right. Times 3 goes into our vector types. Oh, it's a lovely subtract. And there we go. No. AB, right? AB was the input, so it's PAPB. What is pos? Pos, what is that? Ah, yoink. So that's hit position. Hit pos. So that is add f32 times 3. Then moles f32 times 3 with a scalar of hits.t. I think that's right. Yeah, good. Nice. So that's where we hit on the capsule and then it works out the normal from there, which is super sweet. So let's go ahead and get that plugged in. Is that compiling? No. What have I done now? What's it saying? Redefinition of OA. Great. What's overwrite it? Wait, redefinition of PA? Shoot. It's not good. What should we do in that situation? Let's, you know what? So it's the end of the capsule and the start of the capsule. So I guess we call this diff. This can be called hit position A to B, H to A, we'll call it A to B, H to A. Right, so let's try and get that in. Hey there, Wajilla. How you doing? How's it going? H, what about H? It's already declared. What? Did I, what did I do? Yeah. So, scale that. More or less, so multiply this with scalar of H. The sub between those two, and then divide by an R. Not sure I would have worked that out, to be honest. It's taking me a long time. Got that one out. What's an R? The radius, RA. Okay, so we're nearly there now. So we're going to get our hit result. And let's test hitting against this capsule. It should be colored as well. So we get a capsule hit. So ray origin. Ray direction. You want the start, the end, and the radius. So those are things which are going to come in for the vector, I believe. And thickness, I guess. Yeah, so I'll read these boys out. I've already done that in the past, I think. Let's just nick one of these. So let's pop that down. Let's call it a start. And end. Up those by 3 each. Oh. And then we'll do one more, which would then be the thickness. And that'll be a 7. Cool. So with that, then we should be able to test a hit now. Put the standard hit code in where we say, hey, this is a hit. Then take the oh, there's a color in there. Where's the color? Always forget the color. I think that's right. Yeah, color on 8. All right. Yeah, so maybe if we had a shared data structure or whatever, we could just, save repeating that code. But maybe it's not worth it because you see in a minute we'll be doing 2 shape collision checks for this vector 1 anyway, right? Vector debug draw, because we want to make it look nice. So now we've got this capsule, or we should have this capsule. If we go to where we are doing our test code, here we go. So we're going to draw a vector in view space. We're going to go from where should we go from? Should we go, let's take away a 0, 0, half extent x, and then we're going to add a half extent on the x. So we'll just go across the x-axis. Maybe we can do a bit of diagonal in a bit, but let's try that. Then there's a thickness, right? So there's a thickness of 5. Ought to be good enough. We haven't got any Z testing on that at the moment. But let's see that line down the middle. Excellent. There she is. So there's the capsule. The normal seems to be the lighting on it seems to be pretty good for that, but I can't see the lighting show very well for the other one for some reason. So I don't know why that normal. I think our normal's a bit off, specifically for the because say if we colored by the normal on here, norm light. So you're seeing the normal very nice, right? Yeah. So up, right. Interesting though. Yes, right. Yeah. Down. So we need to sort of like see if we can see if our normal does that, right? So luckily we can test it out with the normal back. So essentially, simply just like punch it into here. We've got to make it a float 4, you know, vector 4. Now pack it into a U32 for color. Oh, sorry, it's an unpacker. Right. In that sense, it's that. Right. So clearly, as you can tell, this normal is a fluffed. So I'm not obviously punching in the right. Oh. Yeah. I don't know. It looks kind of just a bit off for some reason. I don't know why. What is happening? We're rendering a debug vector. This is the capsule we're drawing. We're trying to get some nice debug API for shaders and CPU code. So we're making it easy just to put shapes down to represent variables in shader code. So we can debug problemos and solve bugs, you know, squish them. What we're doing. So y is normal. Because I think I copied the code wrong, that's why. Let's have a look. Neat. Yeah, man, it's gonna be sick. That T is wrong. I copy pasted it and fudged it, I remember now. Where's the booger? T, it's just T. T is T. You know? Kappa T is T. There we go, the normal's right now. So, yeah, if we plug... Wait a minute. Yeah, put the color back. Right. Okay, so now we're getting some proper like sort of like kind of shading on this. So it's not doesn't look crap, right? I think so at least. Wait a minute. Let me just take a second look at that. What happened to all my other stuff? I didn't even know what was going on there for a minute. What did I do? Is my ray tracer going backwards? When I went for it. I don't even know. Right, okay, so it does that apparently. What does this one do? 3 and then... Yeah, it mixes the two together, yeah. Yeah, I think that's right. I can't twist it though because it's in view space, but I can do the world space one and we'll be able to find out. Right, so where's my vector? Let's do the view space one. Okay, so it should rotate around it now. Oh. Yeah. So what's interesting about this Rayverse capsule is it works the wrong way around as well. You'll notice if I turn the camera around 360, it will actually render it. The camera control's a little bit squished. Yeah, sorry, 180 I meant. And it's here. Yeah, I don't know if that was... Yeah, so it's not handling the case when t is negative. Should probably fix that, but I think it's fine. The other thing we was just looking at. I think that just ought to be good enough. But we want to make it look far better drawing a vector though, because which way is it pointing? We don't know. So we will improve that. Yeah, let's get the color back. Okay, so color is back. Yeah, this sort of like, hey, if I turn 180 degrees or whatever, I don't know. Oh yeah, if I just go straight through it and I'm behind it. This wants to render behind for some reason when I'm in the middle of it. Yeah, I can fix that. But this one... So t is just negative there, right? If hit.t yeah, so the problem is I've set this sort of success variable where I think the way the code worked when I took it, it said that the way it wasn't a success if t is negative. So I'm paying the bullet by having to write my code this way, basically. But in future, I can just make it better. But yeah, that's the reason. Oh, that's what I meant. Say false. Right, go through it. There you go. For some reason, if I set it to floating point zero, my compiler's like, no, and generates some really weird code. But we can go through it now and it doesn't do the mirror one, at least. Cool. Right, I'm happy I've fudged that now. So the next shape I want to borrow is this capped cone. So I want to stick that on the end, and it'd be like arrow pointing that way. So can we have a bit of a play around? So we can get a normal, right? Nor. I see a nor. A T-nor as well, whatever T-nor is. Oh, it returns a, oh. Oh, it puts the normal in the YZW. Amazing. So that's super nice. Thank you, sir. So there's these caps thing. So we can have a bit of a play. So what does it mean by body and caps? So is it rounded if we don't do anything, right? What does that do? Okay, it just has holes. Right. So I know there was like a rounded one below it. See, capped is probably fine for me. I don't really want it to be pointy. That's probably alright. Like, I could do this rounded one mixed with the capped one. You know, so you do, what you do is you take the, how different is this code? Oh, I'll be needing that later. This one. Oh, this is what I'll be needing later because we're using ellipses later. But yeah, so the caps. So does the body first. The caps. Each one. So which one of these is the top? That's the top. The bottom is the top one. So M1, M2, M3. So I wonder, could you like... Let's take this. It returns an R though. Oh yeah. Alright. What's like an M5 in that? What's a T? Give me the tea, give me the cup of tea. Tea. So I think I was trying to hit the body first. What did I do? So the 5 in that I declared in there, 5, 6. But they're different 5s and 6s. So that's not going to be a good. Where's McKay's though? And they're all declared from these 5s and 6s as well. Boom. Yeah, I'm just going to take the capsule code as it was and not going to try and make it have a rounded top. Because that's just effort. And yeah, effort. What is this vertical? What is that one? Oh, no. Is he not plugged this one in? Plug in. Right, I think that's only okay. That's only going to go straight up. I think. Interesting. Awesome, great there, Liver. Yeah, I'm glad you're enjoying it. No problem. No worries, my friend. But yeah, if you ever want to talk about programming as well, we do have a Discord. So if you want to open up some discussion about stuff, you're more than welcome to come in there and ask questions and that. Because quite a lot of things about C do seem complicated, but there's a very simple approach to solve a lot of problems. So yeah, feel free to pop in and that. Right. Okay, let's bring this one in. But yeah, what sort of stuff have you got? Have you got anything set up in the Ray using Raylib? All right, let's get rid of the ins. They're just ins, right? Let's convert this over into C code from GLSL. Right, so only a few vectors there. Just wanted to see. Then we go into floats. And then we can have a lovely cap on the end. So what's really nice about this one is it has rails and redirection, the start and end, and also radius at the start and end, you know, separate radiuses. Or radii, I think is the plural. What do I know? Yeah. This dot still is like a dot 2. It's shorthand for I saw it. We'll bring it in. The dot with stuff. Oh, I've already got that. I called it length squared. That's all it is. Squared length. Right. Yeah, maybe we can just return these sort of vec4s in a sense, right? Maybe that is the way. Capped cone verse array 3D. Maybe that is the way. Inverse square root. I ain't got one of those. So obviously then it's got to do 1.f divided by... Wait a minute. I do. It's reciprocal square root. I think it's that. Past me is on it. Alright. Yeah, I think this is a kind of good way to do it. This vec4 approach to returning these sort of ray hit stuff is it's pretty elegant, you know. I do like it. We should adopt this everywhere, except probably in that sphere ray tracer I've got, because I need an extra boolean for anti-aliasing or something done like that. I need a bit more information back from the function. But yeah, I do like it for this though. Norm it. Now that is not going to compile down crap. So I need to go ham and just go home from work. Cool. Didn't know missed the weeks. Don't know if I'd miss the weekday streams. Oh, okay, fair play. Oh, you missed Tuesday's one as well, maybe. But yeah, we've just been doing the debug drawing stuff. We got a sphere. We got depth testing as well now. And what else have we done? Yeah, we're doing this. We're getting this cap working, so we can have a nice little vector arrow. Really, really nice. So it can actually look kind of cool and useful. when we debug draw those vectors. But yeah, how's your debugging campaign? I replied to your message. That's alright. I'm currently recreating the arcade game Asteroids. Oh, yes. I've done that. It's good. It's good. I don't want in 3D where it did a repeating 3D world with asteroids. It's quite funny. Because basically I took the inspiration from like, you know, in asteroids, in 2D, it's like, well, if you take your asteroid, sorry, your spaceship from asteroids, that's what I meant. Fire. When you fly off this way, you wrap back around and go here. So it's like, in 3D, it's going to be just a repeating world. So you can sort of see off forever into the... So I did that, it was fun. Good times. Oh, these are meant to be subs. Bruh, subs. Right, so I'm going to convert all this into... Right, multipliers. And then a couple of subs. But not the sandwich kind. And subs are so expensive now. Go Subway. It's a lot for a sandwich. But I guess it's the more healthier fast food, you know. You know what I mean? What are all of these? Oh no, some of those are scalars. Well, it's not that much of a thing. I just got to add an S to it to say, hey, the right hand parameter is a scalar. But yeah, anyway. So thanks to multiplication, it doesn't matter about the order of those things. So it'll be a mul S and then a mul in the middle. Oh, and I forgot to put commas here. Ugh. Comma. And these are scalars, so they have multiplication syntax. So this is one of the things I could have added to my compiler. Just added support for vectors to have like this syntax, because it is kind of nice. And then for shader code, I could have just like used this. But anyway, it's alright. Not the end of the world. Sort it out. So any more of these sort of like this is all scalar maths, I think. This ain't scalars though. Onto my subs. Is RA a float 32? RA is a float 32? No way. I didn't have to change this the whole time. I was getting confused by the rays. Burmese radius, not ray. Right, let's give that a go. No, what's the BA? BA is a damn vector. You negate the vector. Then you mull it. And then... Oh, with a scalar, of course. Holy, yeah, Yeah, preprocessor. It doesn't like it when you don't close the things correctly. Alright. What? Implicitly cast to a float? What are you talking about? Right, one of the macros. I see ya. Yeah, I don't have a way. Wait, I might have one of those. Somewhere. There we go. Times 4 SV3. Yeah. Past me did it. Probably not the best code gen though, but it will be optimized. Oh shoot. Expected identifier for field you wish to access from that. Right. Yeah, my compiler's got a bug with macros, I guess. No? Yeah, I think it does with that. One of them, eh? I'll just store in a temporary variable, it's no biggie. No biggie. Do you still have that buffer overflow thing happening? Or did you solve that? Buffer overflow thing. I don't remember exactly, but what we have is... Okay, validation error. I haven't got a proper binary loaded. Oh, I know. Yeah. So, I know the one you're referring to now. So, I was rendering the spheres, and you get too close to the camera or something like that, and they start glitching out with the tiles. Yeah. So, I still haven't solved that problem, because we ran this suite of debugging stuff to make it very easy to sort of figure out what's going on. I know it's something to do with the screen access line bounding box that I'm making. So, but we'll be able to see that all very soon. I'm just getting all the foundational tools that I'm going to be using, so I don't have to come back to this and do too much more work, basically. I'm sure I'm going to have to add more as time goes, but just all the basic ones. Like, can I put a point down and see where that is? Can I put a vector down? Can I put a box? Those ones, you know? In world space, view space, screen space. But yeah, well, building dev is kind of K. Haven't had much time to do more work lately. No worries. No worries. Know what you mean. Right, so let's fold this out and give it a little bit of treatment. So I need to get this. You know, okay, let's just do the good old. Rightio, we're in. So I just got to go ahead and plop that into lovely temporary. And I'm going to call it temp because I don't even know what it is. Oh, it's the norm. The normal. That's what it is. So basically we want to construct like one of these boys. I can just call this N probably. And keep with the fashion of unreadable code. So we're going to continue that on. Yes, so Rightio. Very nice, very good, I think. No, I just deleted something I needed. Cool. So, we're all the way down here apparently, it's good. This one, we need to make a new norm. A new n. Says the normal. No doubles. No doubles. Alright. Holy moly. Right, which one of these are vectors? Oh, they're all a vector in some way. Oh my days. Prepare for syntax. Prepare for syntax. So, the m's are all scalars. Okay. The m's are all scalars. That's a vector. T's a scalar, that's a vector. So that produces like a hit, or what's the OA? OA is right from the ray origin to the start. Okay, so it's the right. So this gets you the yes. This gets you the hit position, basically. From it gets you the hit position. Wait. Ray origin. A vector towards ray origin from the start of the cone. Then, so you're saying along the ray direction, travel down T. Add to that, okay. I'm trying to think if I can put some temporary variable names down. RR. What is that? R. Right, the difference between that, right? BA. Yeah, BA up there. RA. That's a lot of stuff. Just squished. Right, I guess let's just give this the treatment of right, what's the HY? Scalar. Y is a scalar, right? Yeah, good. So we'll just start here. So those two are scalars, so you have that syntax. Then this is part of subtraction. Wait a minute. Yeah. So then a sub. Like that. Scalar. So what really what you're saying is this is a mul-s like that, with this being a m0 squared. Then there's an add that goes on with another vector which is composed, that's a scalar, by a mul-s and a mul between two vectors. This is a lot of stuff, a lot of things with RR on it. Right. I'm glad I just made that less readable. Pat on the back. Right, so apparently it compiles, right? No, of course not. Oh, I forgot to get this one going. So this is a mul-s. It can get even more readable, don't you worry. And then an add. Right. My finest work. Wait, RA is a that's a float. Interesting, RA is a float. So that's just like that. Oof. There's something incredibly oh, multiple errors. What's going on? My compiler does do multiple errors. Not enough arguments. Expected 2. Right. Brackets have not been closed correctly. Is it like 3 parameters here? Oh, you booger. Right. Oh yeah. Yes. Amazing. Yeah, it's alright. It's a type of code where you just like I don't really understand it anyway, so I can try and decode what's going on, but it will take me a long time. So it's alright. Uglified. We should have maybe put operators for vectors in this compiler. It would have been probably would have been a good idea for some shader code. Audio. So let's plug it in. Let's see if it works. So this is good. I like the fact it returns a float 4. I'm like, that is good design. So maybe we should have changed the other things for that as well. So this is actually the last shape for our 3D one. It's gonna be good. So this is hits. I guess I'll wrap these guys in a type of scope so I can just reuse that variable name because I just want to reuse that variable name. Yeah, I've already got swizzling, which is kind of funny. Right, what's this called? Capped cone. Ray origin. Ray direction. Start, end. Thickness. Now the thing is about thickness. There's one end of thickness and there's another end of thickness. So I don't know. And also start end is a bit too much. So what I might do is say whatever the thickness is, you know, I don't. We'll probably say this is thickness times 2, and then this will just be thickness. Now the start and end obviously is I need to figure out what the actual start is going to be, but let's just see the cone in 3D, and then we'll go from there. So if hits.x is positive, then we can then do that's t, right? X. The normal is hit.yzw. And look at that swizzling in C. Yeah, I added that. That was fun. Right. So we should be seeing a big cone. There we go. We're seeing it. I think the normals are working out alright as well. Should we debug that a bit? There's the capped cone. It should be right. Let's debug view that thing. So it was like a for hit.y, hit.z, hit.w. Yeah, so seeing the normal now. Can we get past it? No, okay. That's fine. Yes, that's red on the tip there. And then around the other, down the bottom should be blue. I don't know if I can tell that, to be honest. Yeah, it's blue there, you can see it. Right, so I think that's alright. I think I stole that code effectively. So now we get to figure out how do we place the start. So I think I did the thickness thing okay. So I guess the right way around, basically the parameters. So I'm debug drawing a vector. You've specified a start and an end. Then you've specified a thickness of the line. So what I was thinking about doing is making the cap 2 times the thickness here. Maybe that's not enough, right? And then it obviously goes down to regular thickness down there, right? So how do we define, do I just define the length as thickness times 2 as well? So I think what we do is we say, so there's probably a capsule end. So capsule end cone start maybe. So we'll probably say like cone start. That is going to be, so you want to effectively get like a line going towards the end. And so you want to get that sort of vector. You then want to calculate, you probably want to normalize it, I think. And then you want to give it the length of thickness times 2. Then with that is the kind of offset. So what you need to do then is subtract this from or end, right? And that will give you where you start along the line. So we can say, hey, draw the capsule up to there. Then we can say start the capsule from there. And I think that's kind of what we want, but we might want to make it a bit thicker. I did a thingy wrong. What did I do wrong? I thought that was all good. Oh, I didn't define it as a vector. That would help. Okay, so we kind of get the tip. You know, the tip looks kind of nice. Maybe what we could do is let's probably increase how thick. So we probably want to say like, so maybe we do this by 4 or something. Times 4. Why am I seeing this? Surely this has further depth than the capsule. It's a bit weird. Is this been drawn in front? They should be z-testing with each other, right? Oh, the test depth didn't get reset up, damn it. That's why. So I guess you should set test depth as well. That's the problem. There you go. Oh. Right, I got a split. Good seeing you. Thanks for the stream. Have a nice weekend. You too, VMC. Have a good Easter break. I hope you got the Monday and the Friday off. And yeah, have a good one. I'll see you in the future. And I'll probably chat with you in the Discord and that. But yeah, thank you. Good to see you again. Right, so I think that's nice, but maybe maybe this should also be kind of like a ×4, like the. And then like if you don't, the thing that you got to be careful of is like if you have a very small vector, then but a bigger thickness. So we need to make sure that the thickness. So you get the length of the. So probably when you make the I don't know. You want to get like the length of the vector, right? Whatever the length is of that vector, you want to make sure that the thickness is equal to probably the min or the max. Oh, what is that? The maximum, which is so if if the length of the vector becomes so small, then the thickness needs to be needs to be shrunk down. Hey Vala, what if thickness is 0? Vector like a sharp cone. Also, what if negative? Bum, bum, bum. Well, we'll just hope this positive, but yes, that is true. There's tons of invalid state, if you will. Hey, Atis, yeah man, doing well. Doing well, I hope you're doing great. Feeling much better. As you told last stream, I was really ill. Unfortunately, I felt like I got iller as I was streaming. It was just weird. Yeah, but now you can just tell my voice probably still got better, to be honest, but it's going away. So I think by Sunday I'll be all in the clear. But yeah, do good. I'm off tomorrow and Monday, so it's gonna be nice. Gotta get the house back in order. I got for a barbecue. I got tons of things to still clear up. There's a lot of rubbish. Also missed the recycling bin as well, so there's just tons of rubbish out. Need to get that all sorted and in the dump. Yeah, luckily I'm the user, but yeah, if it becomes a problem, I'm just gonna hard code it. Pretty sure. But yeah, you're right. We probably should do some stuff like that. Yeah, baby. My wife is looking after the baby. Yeah. Seems. Yeah, I'm not sure what she's doing, to be fair. We gotta check. How about we try the wrong values? Or the GPU crash? Don't you dare remember GPU crash. No, it should be fine. No. Let me check on this baby. BRB. Alright, welcome back. Yeah, baby's good. Baby just woke up and needed a change. So, yes. He's just being fed now. Oh man. Yeah, so the thicknesses. So, if the length is smaller than the thickness, or not even the length, because the thickness is you're times something by 4. So kind of like, maybe we need a division instead of a whatever, but yeah, so maybe we should put in like, hey, how much do you sort of scale the thickness by, or whatever. Thickness. Okay, so there's already thickness on the capsule, but it's more of like, probably like, you could probably call this like cone length. Yeah, and that is thickness times 4 or something like that, right? So we can just do something like that. Oh yeah. So then we sort of say, okay, well, maybe so if the cone length, so if the length is smaller than the cone length, you want to use maybe I'm putting the wrong thing in. Yes, I think it wants to be divided by 4. And do that. Just think about that. So if you say, if the length of the whole vector is no, but then you're gonna set it to that. Oh my days, damn it. Thank good. Thank good. So maybe I just want to do an if statement. Screw this min. So if the length is less than, then thickness because the thickness is going to be multiplied by 4. So if it won't be multiplied by 4, then the cone is automatically going to be bigger than the length. So we divide the thickness by 4, and if that's still bigger than the length, then we have to make sure that the thickness is length divided by 4. And then that way, it will be the exact size. And you won't see anything though. But hey. So we can try that out. So that still works, right? You got your arrow tip. I don't know, but like, anyway, we can have a play about it and see what it goes. So vector view space. So I've got like a 5. So I don't know. So let's say a minus 1 and a positive 1. So that's 2, right? So so thickness divided by 4, if it's less than length, then it's going to sort of cap it. So that should already take an effect. Oh, I think we've gone and fluffed it already. What glitching effect? Oh, with the spheres. That's the bug we're trying to... Well, the spheres sort of glitch. Yeah, that's already a known problem. That's what we're writing all this debug stuff for. Yeah, all of these. You see all this? So effectively, we've got this view space box, right? And the Z test it. So we've got that, which we added today, which is nice. So we've got these spheres, and they're being ray traced. But to accelerate the ray tracing, we bin them into screen tiles. And so what happens is when you do something, which they're like that, right? The spheres are not binned correctly into the screen tiles. So what we're seeing is you're seeing tiles have a bit of a problem, right? They're not fetching the right spheres or something like this, and they're ray tracing it's the wrong spheres, and it changes every frame. So effectively, we generate a screen bounding box from this view space bounding box, and it's wrong. So I've got the debug shape for this view one, so we know that's good. But it's just when we do we've still got to do the screen debug shape, which we'll be doing after the 3D stuff is finished. So we're literally on the last 3D shape now. And then we could just be able to do this lovely API, which is good. But for some reason, I think I've completely scuffed. Yeah, so I think I do need to have some edge cases or something. I don't know what's going on here. So length is always positive. C language, yes, yes, yes. Right, 0. Great. How did I deserve this? Because I did -1. Okay, so it was 0. Then we're completely done. Messed it up. Let's handle for this case. Because that's not good. So that shouldn't put anything on the screen. What the, why can't I see stuff? Like, you're just gonna be doing... Do I really have to put an if statement around the whole block? If len... Oh, did I do greater than or equal to 0, didn't I? Let's do this. Anyway. Alright, so now we're seeing stuff again, but we're not seeing our vector show because it's got 0 length. So we go to the drawing where we put it. I did subtract -1 and add 1. So what happened is the same thing. So that was the problemo. Alright, so now we're seeing this. Why are we not seeing anything else? Nobody knows. Is it so big that it's... Right. That's weird. I think my conversion code... I changed the thickness parameters around. Oh, if the length is bigger. No. Hmm. Right, let's try another small number and just see if we get something still. Okay, so these small numbers are working fine, but when I do the bigger numbers, it's like, But if I did a larger thickness, like a 15, it just wants to render that only. Right, I think I know the problem. So because that'd be 15 divided by 4, that's bigger than length. Yeah, it's bigger. The thickness is now going to be length divided by 4. Length ends up being what exactly? Right, so 2 divided by 4, then you got like a thickness of 0.5, right? Then cone length will end up being will end up being 2. So you're then saying, right, so what ends up happening, I think, is they end up being, start and cone start end up being kind of similar or something like this. So I think maybe we need to probably take away like an epsilon or something. Holy, what? Right, so I think that worked. It's just, yeah, the print code. Okay, there you go. It's pickle pickle vector thing. Um, yeah, yeah, Maybe I think the cone sort of thickness, if you will. Maybe cone thickness should be by 3, maybe. Slightly different. I think it's just a bit too tall, you know? And this should probably be divided by 6 or whatever to make the other ones, to make them, when it's a small, extremely small vector, to not be probably, like, look a bit wrong. Yeah, I think that looks better when it gets clamps at least. So you can still at least see a cap on it and whatever. So let's make it so Right, vector v space? Yeah. So now let's increase this. Let's make it 3 and 3. I made that a thickness of 15 still, so I think it's still going to get clamped. Holy moly. Thickness of 15. Let's do thickness of 1, see what happens. Ooh. Yeah, something wrong is happening then, as you can tell. So because I made that 15, this is huge for some reason. Or because of that thickness parameter. And it's been off-centered a bit. That is not good. So this is caused by... so we get the length. You know the length. So you start taking, normalize it, multiply that by cone length, then take away, I guess your cone start. That makes sense. So that's 15 divided by 4. The length. The length is probably about 6. So it probably doesn't hit this. So then that'll probably do... Oh shoot. Why is that divide? That should be a multiply. Yeah, by the biggest... Right, I see. Alright, that's where the logic went a bit wrong. Okay, now it's corrected there. Still clamped. So... Right, so now increase this to some... So that's this 15 thickness. So now that's clamped. Let's make it actually big now. So let's do 15, 15. So the length is obviously 30. Right, it's going 15 to the left, 15 to the right. Length is 30. So this thickness times 4 is still going to be a bit too big. Right, so it's going to get clamped. Okay. So it gets clamped to that. So if I reduce the thickness now, this cone will be a lot smaller. Let's put it to 1. We see a nice long vector with, there you go, with a tip on the end. Excellent. So, and that's centered in the objects there. Cool. Got a bit of lighting on it as well, so we can sort of tell the difference between things. Okay, so I do kind of like how that works. It deals with, like, I think that cone kind of looks alright. I was hoping to probably get a bit of a rounding on it, but yeah, I'm good. We could. Yeah. Yeah, I was thinking maybe trying to get a bit of a rounding on one of the ends, but I think that's fine. It's good enough, I think. Because I already got a rounded edge here. You know what I could do? I could just move the capsule a bit forward, and maybe that will just be it, right? I'm already rendering it anyway. So why don't we just get the... Well, I'm already ray tracing against it. That's what I mean by rendering it. So why don't we just do that, right? So rather than doing cone start on the capsule and stopping it there, let's put it at the end and see how that affects it. Right, so it just pops out, and the normal is a little bit off. So I could bring it in a bit, but that then goes to okay. Yeah, but then that would be extended out way too much. Also, that's invalid. What's nice about the capped cone is it stops on the point. The capsule, however, doesn't stop on the point. And then that means the other end doesn't stop on the point either. So that's something to think about. The actual end of this would be... maybe I should swap out for the cylinder. Because then a cylinder, you can't go wrong. With what you're looking at. It'd be a bit more ugly, right? It's a bit flat, but... So there's the cylinder. The capsule... Capped cylinder. Infinite cylinder. Ooh, maybe not. So that's probably very similar to the capsule, I imagine. So... What do I have to change to get that to work? Body... So there's a H. Okay. Yeah, I think we should switch to this cap cylinder, not gonna lie. It'd be better. How you spell cylinder? Yeah. Can we get it to return a... yeah, we'll do the flip 4 trick. I'm all on board with that now, it's good. Where you got the T in X and Y, Z, W are the normal. So basically, let's just change this over. Oh, okay. So H is where it's different. Oh no, the whole thing's bloody different. Right, swap over. I joined recently, so I might have missed it, but why is the cone not pointy? Because I have stolen it. That's why. There's not a pointy cone here, that's why. I could probably figure out to make it pointy, but that's just more work. It's somewhere about one of these boys here. Basically. Just gotta figure that one out. Or maybe, you know what, I could just keep the capsule. Because it's just more work. Yeah, let's keep the capsule. But we're just gonna make sure we start the start. Plus thickness. Because if not... then it's not correct. That ought to do it. So we've got to test again the sort of smaller. things. I think that's right. Stop this end. Yeah. So let's change the vector 3D. But yeah, how's it going, Mr. Rosmosco? How you been? How's it going? How's your VR project going? Did you saw that those render passes? So if we make it like 15 or so, then that'll get clamped. It's going slowly. Yeah, I can imagine. Vulkan and stuff. Interesting. Yeah, that was capped right. Yeah, it's good. Maybe I want to reduce the cap still. Rather than divide by 6, probably divide by 8. Give it. Yeah, so even when the thickness ends up being bigger than the length, we reduce the thickness so much that it still gives you kind of an okay looking arrow in a sense, right? Yeah, I wonder why it's not like a cone, it's a capped cone. I wonder why there's not a kind of a pointy cone, because surely that's like not too... Hmm. Just set one radius to 0. Hmm. Give that a go. So what you're saying is... Oh yeah. That's gonna poke someone's eye out. Oh my days. Is that good? Right. So what's also coming in with the stating the obvious. Yeah, just set it to 0. You know, and all be well. There we go. Look at that. That looks good. Thank you, sir. Yeah, so vector is good. It's good now. So we wanted to look at the bounding box again, because what we've got is an axis line bounding box, but we haven't got an orientated bounding box. The way... Okay, wait, let me just test this on a... Let's do one diagonal test. 2 seconds. And let's do Z testing as well, I think. I think this just is going to be a bit... Right. We want this to be a bit longer. Let's do 30. And then we'll Z test the crap out of it. Oh, it's just still not outside. Maybe I should have stuck with the 40. Let's do 45 then. Alright, there we go. It's purely, it's definitely going through these spheres. So let's put the Z test option on and just double check that it works. There you go. So that's going through the spheres. Sweet. Obviously that glitch is there, we've got to fix that. That's the reason why we're doing this debugging drawing stuff. Alright, so I kind of, if you take a look at my bordered box thing, where is it? Bordered ABB verse ray. So I took my ABB verse ray from another project and I sort of botched the crap out of it and done a border thing and done a normal. But I don't think this is as good as it could be. And I think as well it would be better if I clean it up and probably take the version from here, because when we do the orientated bounding box, what I want to do is we're doing a array verse orientated bounding box. So what we need to do is we need to transform this ray. So originally it would be like this and orientate that way, right? So we need to orientate this. So we need to go from like view into the local space of the object. So we translate the ray instead of the box. Do the detection, do the ray verse box here, and then use that information and take it back into view space. Right, the normal and that back into view space. And that's how we're going to deal with it. So what's great about this solution here is that it works purely based off of the maths is based on that the box is orientated around the middle. So I think it will be easier to do the OOBB with this version. So I want to give that a go. So we're going to sort of take this and try it out. So we'll call this one the out normal. So it produces a near far. Did we need a far in the end? I think we just needed a near. Oh no, we wanted the far for the we wanted a far for the. Oh no, but we didn't. It bordered. Excellent. Yeah, so we just do one of those vector fours, right? ABB bordered ABB verse ray 3D. So let's adjust this. Oh, float 3. Okay. So yeah, this is definitely not safe. So should we get the safe version, I guess? There's the new M. ABS mol box size. Now n says negated vector plus k. What's the k? Another vector. Oh, that's a sub. Don't mess that up. Right, Tn. So this way you get to your floats, your scalars. That's the max element. Thank you very much for the follow. You're in that 4K follows. Then min of T2. So near far. So we've got to add our special border code as well that we have in the other one. So we're going to definitely change this around. So obviously no intersection. Let's put that comment in there anyway. Right, so all of this stuff. What is going on here? Out norm. Yeah, so we fixed our step function last stream, so that's nice. Let's splatten all those out. What's the T1? That's a float, so I need to use the step S function. Okay, so I think that's alright. Let's call it N for normal, right? We'll keep with the unreadable names. So, right, F30 times 3, N, delete that. Okay, so what we're going to do is we're going to try this out, and then we'll add our border code in there, and I'll go over how the border code works. So it's here we want to use TN for now, the nearest hit. But when we do borders, we're going to actually want to use the stuff behind it as well. So do n.x, n.y, n.z. So the normal is in the last 3 components, which is awesome. I like it. I like it a lot. So basically we'll end if this boy, and we'll if 0 that. Come back to that in a minute. So we'll get rid of the border thickness. And is it put in the... Probably call this like a half size, half extent. It's a better name. Pretty sure it's a half extent. Must be. Yeah, it's centered. What else would it be? So the thing is, we're doing like a min. This is another reason why I wanted to adopt this way of doing it, because we're passing in like a min and max in view space, which is like, I don't think that's going to be the way I'm going to be defining most of my bounding boxes. They're going to be centered positions with a half extent. So I want to be that as the main way of doing it, but then probably offer both as a function, then just convert into the other one, right? So for now, we're just gonna, you know what, actually, let's just convert it over. It's not too hard. So let's do center position in view space. Let's go and swap all those out. That's in the CPU side code. Let's get in there. That's the GPU side code. Then the max in view space will then be half extent in view space. I think I use the word dims usually, don't I? I usually use the word dims. So let me rewrite that. Now we're going to change the CPU side. We'll change the lovely header. And there we go. So that's the excellent bounding box of view space. Renamed there. So let's find that so this is where we actually put it, call it. So put the center position in there, and then we just dump the half extent, or the half dim, so we can call it, in there like that. And that's typically how I want to use that anyway. So again, let's do pos center position of view space, half dims, and plop it in here. Center. Well, there's no center pos because we've got to translate it. So what we've got to do is actually do a sub here. Well, I could pass it in. Yeah, I've got to do like a subtract. Sub this. So we're going to go towards the ray origin, and then you want to flip the ray direction, I guess. Oh no, ray direction stays the same. From center position in view space. Okay. Oh, what did I mess up? Oh, these aren't step S's. Don't mind me. How do you compute the normal for the cone? Just be aware of the pointy end. It's here. In here. Let me change the. Oh, it is. Maybe 0 is not good. Perhaps I should test actually that this vector is the right. I need to test a bounding box and a vector to make sure they start and end at the exact same place. But yeah, I don't know. The normal code is in here. It's oh, it's in the capped cone function itself. Into both functions. Oh, so you think it's the capsule pointed through? No, I don't think the capsule goes through. But yeah, we should look into that. Oh, I don't know, damn epsilon. Yeah, we'll look into that after we just get this box rendering. Because I can't see the code. Or the results, sorry. And redefinition of n. Oh. Right, negative sign. Wait, RD, that's so negate. Okay, so that's a float for x greater than equal 0. Maybe it's greater than 0. I don't know. It should be greater than 0. whatever the near is, I guess. But yeah, x, the normal is yzw. So we can debug view that normal as well. In a bit we can do that. What? Undeclared ident. Oh, in. Alright. So apparently we've seen the box. Good. And the normals are actually looking good on it. My normals were messed up on the edges. These are good normals. Okay, this is a good box. Should we add the border code? Actually, no, maybe we'll add... Let's look at that, let's look at that normal. For that vector. So what we can do is we can actually spin it around the other way. What I'll do is I'll say, hey, 45, or 0, 0, I don't know, 25. Same thing for this. So go towards the camera. And then we'll disable the Z testing. And what we're going to do in the renderer is we'll just display the normal as the color. Oh shoot, I want to get rid of the other one. That'd be fine. Oh, it's going the wrong way. Just what we want to see. So it's blue. Seems alright, doesn't it? Well, it's white. Wait, why did you get a white? Yeah, so I'm only displaying the normal for the cone, not for the caps or the back. Let me try the other one. We get the code from. Oh yeah, I gotta disable. Norm. Oh yeah. Easy as pie. Right, that one looks a bit different, doesn't it? Yeah, the normal's probably wrong. Right, so whatever I did to mess with this code, I've done the calculation wrong. And it seems like, is it the cap that's wrong or is it all of it that's wrong? Have a look. I should just probably double check the code. So I have to convert it over. So let's double check it. So the subtraction. But first, a couple of multipliers have to happen between O, A, and M3. M3 being a scalar. Then RD and M1. Yep. Less than RA times RA times M3. Yep. Then the result is for the normal at least is the negate. You negate. Oh, we should be negating first. That's the way operators work, right? It's a unary op. So it negates first. Not that I'm sure if that matters or not. Okay, then a reciprocal square root. Yeah. Right, that's good. This one is OBM3. OBM3. Cardi, yeah. Then the dot is just a dot with itself, yep. Length squared, yep, 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 yep. Less than RB, RB, M3, M3, yep. Then BA, positive BA, M2, M3, yep. Okay, so that's looking good. Yeah, it's probably better, isn't it? Yeah. To convert into unorm, isn't it? Yeah, let me just double check this, and then if it doesn't look the same. I wonder why this one isn't shown black though. So these two are multiplying with right, I did my multipliers wrong, I think. No. You multiply that, then you add. Crap, I buggered something up. Sorry. You do all of that, which is the add. Multiply that, then the add, then multiply. I think I messed up. I messed up the order of this. So I think it goes that with one of these M0s. Oh my days. Then it's an add. Yeah, I think I completely messed this one up. Let's just quickly figure that one out. Right, so here's this code where it calculates the redirection multiplied with t. That's that code. That's then multiplied with an M1, M0. Yep. Then the result of that is then added with the result of those multipliers. So here's these multipliers. Where does that one go? Onto the add. Excellent. Then there's a multiply with that. Yep. Then there's a sub from that. And the result of all of that. And then you norm it. Right, okay, I think that's the that's what's wrong. Let's try that out. Yeah, that normal's looking better. It's looking better now. I don't know why the other one's color is like that. Did I? Because that looks like it's not showing. Oh, for crying out loud. Yes, this one looks like it looks great, basically. If I turn it to, that's signed norm though from -1 and 1. So we are gonna get, yeah, we should basically do like a, just to sort of see it look a bit nicer. Hmm. Is that what it would look like when it's signed norm? What did I do wrong? Because you're half in it. No, 0.5. Hmm. Maybe that's what it's supposed to look like, I don't know. But yeah, so why when I colored this one with the norm, I just said color equal, it does the gamma correction. Then it applies a total sort of color. It does anti-aliasing. Oh, then it does rises like an 8. Like a super sample, I think. Okay. Yeah, that's right now. Yeah, I think so too. Not sure what I did there though. So let's try and put some proper color on. Thank you for picking up on that. I don't want to see that. Yeah, it looks alright. So the reason why we're seeing it lit both sides is because of the way I do the coloring. Uh, I don't do a max on it. I do like an n.l basically, but I don't max it. I ABS it instead. So we just did max it for a second. You do a 0 negate. Let's try that out. Oh, then I fudge it a bit here. Yes, the light's only coming from over that way, or whatever. Yeah, turns with me. The light's coming from probably behind me now. Yeah, there you go. That's alright, isn't it? Voila. Thank you for that. Appreciate it. Oh yeah. See, I wanted to test out a couple of things now. Well, I want to get the bordered code into that new AABB thing, because that normal's now corrected, so it's good. But I did some lovely border code. So effectively, when you're casting an array through a bounding box, what you need to calculate is, I guess here's me trying to do it earlier, is you've got a center position to, so your ray goes through it, bam, hits there, right? There's your hit point. You're drawing a vector from the middle to the hit position. Then what you need to calculate is, so you only want to draw the border if the hit position is close to two faces or more, right? If it's close to 2 faces or more by the border thickness, then you are at the edge. So that's all this code is doing here, basically. So we just need to grab that, yoink, and put it into this new one. So this new one works with like the center of the center of the bounding box is at origin 0, 0. So this means that this border check is actually going to be a lot less code and calculations. So I guess we can just calculate the normal. Right, so this calculates the hit position. And this will essentially be center to T max vector. We need to do a center to T min vector as well. So T far, T near. All right. So what we've gone and done is we've gone to generate like, we've gone from the ray origin, which is here, right, down the direction, and using the T values you say, hey, this is the nearest hit, this is the furthest hit. Down there, right? That's the furthest hit. And now we've got those two hit positions. Those are relative from the middle of the box. So we don't need to do that extra line of code which used to exist there where I did a subtract from the center, because the center is, you're in that space, right? So that's really nice. So now there's those less things we have to do. And then we just now need to say, right, if we sum the elements, so we sum x, y, and z, right, of these integers, which are a Boolean, it's a Boolean result. It's kind of like a Boolean vector, right? 0, 1 in each component. To do a less than operation, we're going to do a subtraction between the half dims and the absolute vector, vector of the center to the nearest hit. Sorry, the hit on the near side of the bounding box. This will give us this will always give us like a positive value. So we're saying if this is less than, the result of this value is less than the border thickness, and if two of them or more are along the x and y and z axis, then this means that the hit is close enough to the edge of two faces, two or more faces. So it could be in this corner, or it could be sort of here by the amount of border thickness that you want. And then, so that means we should return T min, which in this case is Tn for near. And then if not, it's T, and then you do the same for the far, and that will say you're at a TF, right? Now, if not, it's infinity, blah, 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 blah. So now, rather than returning Tn, you return T, this new T. So it's either the near or the far. And that is border thickness. That's great. So we should be able to put that back in. So border thickness, give it a go. Hooey. Oh. RD for redirection. Half dims, you say? Alrighty, so let's give it a run. And we see absolutely nothing. Is it because we disabled the box? Or is it because my code just simply doesn't work? I disabled the code. Excellent. Alright, there's the bordered box back. Isn't that lovely? So, seems to be working. What I want to test next is this vector the same as the banding box? And then we've checked that they are good, both good. So if we do half extent dot x, we go back to that, and I want to see like how does it measure across the okay, so it's hard to kind of tell. Why don't I do sync? Yeah, I should do that, isn't it? I'll do that so I don't have to do anything else. Yeah, I don't know if this is exact, so what we're going to do is we're going to put an inf on the border thickness and probably change the color of the yeah, hey, run a goblin. Yeah, these aren't the best skills. I just took the code from the internet like every good person does, you know. How's it going? Yeah, why didn't I do that? There we go, it's in my history now, so I'll do it. Thank you, sir. So if we increase it by, see the thickness is 1. So if we increase it by 1, let's just increase by 1 and just sort of see what's, oh my nose, right, we see it go through just a little bit. I don't know if that's the length of 1 though. So what is the length of 1? So I guess the thickness is 1, which means the cap length is, what's the cap length? The length of the cap is typically 4 times the thickness, so it'd be 4. So if it's 4 times the thickness, and if I did 4, we should see it poke the cap. Oh, why do I do that? The cap all the way through. Still hard to tell. But I guess if I did a tiny amount over that, at 0.2 or something, how's that go? Hey, Fair Writer, how's it going? Yes, it does poke a tiny bit through. So, I think it's safe to say that that end is fine. And maybe the other end is fine as well. But that is a distance of 1 because we guaranteed that from when we did doing okay, I got my baseline PBR working now. Wow. Trying to figure out some Alamodel. Sweet. I've not done that yet. That's something I want to do in the future. Yes, that's the size of 1. That's good. Alright. So we're nearly finished with this debug rendering for 3D. The 2D one will be a piece of cake, because I've already done the SDF one before. So I just want to sort out the orientated bounding box now, and then we can call it a quits. How's it going? Yeah, doing good, doing good. Just happy we're nearly finished with this debug shape rendering, so it's going to be super helpful to debug a lot of variables and stuff. And so we can actually render these spheres a lot better. Figure that one out. Yeah, what do I want to look into? Yeah, an orientated bounding box. Should we do one of those? So I want to do like an OO, no BB. So view from local, border thickness in local space, color Z test. So I've already got view from oh yeah, it's right here now. Yeah, I think this is wrong. I need to instead multiply. Yeah, I've had to think about it. I've been thinking. Let's Z test false for now. So what I've been thinking about is we probably need to do like a so each axis vector you'll multiply right, so what am I hoping this code does? So I'm a bit unfamiliar with matrices here, but I'm hoping. So this is a view from local matrix, and in local space, -1 to 1 is the size of the box, I think. Yeah, -1 to 1 is the size of the box. But what I want to do is yeah, scale it accordingly. So this could actually be. I probably need to use the U norm and not sine norm here. So the problem is the clusters will be different sizes depending on the LOD. So I think I need to scale this with no, yeah, we cluster dim sine norm actually will be that one. So it ends up shrinking shrinking the local space basically. So we're going to translate the ray back into local space, do an AABB verse ray, and then transform some of the other stuff back into view space. I think like the normal maybe needs to come back into view space. So I think I did like a inverse. That's what I meant to say. So I think I might revert that and do that in the shader instead. Excuse me. I think I might just stick to outdoor directional light plus shadows and light spheres, but then again, deferred lighting is really tempting at this point. Yeah, lighting is important. It really depends on the style of your game though. But yeah, typically you want correct lighting, but sometimes you really don't need it. It all depends on the look you're going for. I think I want to try a PBR thing for this game because I've never done it. I've obviously played around with code that's PBR and whatever, but I've not actually done it myself. Like I've used like PBR, messiness, roughness, and albedo, and that played about it in like a G buffer, but I've not written the sort of stuff behind it or learnt too much about it. I have read up a little bit about it. Yeah, consistent, I guess, maybe. Yeah, the thing is that you will fool a lot of people if it's not fully correct. You'll only, but you wouldn't like, but as long as it's not distracting, you know? And I guess that level of distracting changes on the person who can sort of account for what you're not doing or whatever. Like, I think if you look at some old games, they just do it just fine and they don't really do it all correct. Yeah. Using approximate PO as more like image-based rendering. Okay. I need to look into that term again. I remember reading up on it, I forgot. So that's the GPU code. Let's change the CPU code. So we can code that into a buffer. I'm going to pull it out, right? It's how you deal with different. It's how you basically do unions in GPU. Just put it into an array, and it's just 4-byte element size. So we're going to go ahead and fetch this boy out of the buffer. So we make ourselves a view from local. Now the way I think this is going to work, right? Right. Hear me out. So you're going to orientate bounding box. So what we really just want to do is do an AABB verse array, right? So if we simply transform the array, so we invert the view from local, and then we're going to take our array, which is in view space, bring it into local space, and then same with the direction. Then so then because you're in local space, the box is already in the center, so I don't need to do the subtraction anymore. Then the half dims, because we've changed the scale, I think in the shader, I need to make a function that does this if another function that will do this automatically. But because I've changed the scaling of the axes, I think this means I can just use normalized I can just do this, right? Half dims in local space. I think I can just literally do this, and that should be fine. Wait, they're half dims. Wait. Yeah, there's one. Border thickness. What do we call that again? Border thickness in local space. Good. Okay, so I think that is literally how it would work. So hopefully it's good. So I want to do a different color. It's doing it as white. It's doing it with a border as well. Okay, let's try that. Axes. These. Okay. Well, RTX gives us a chance for correct lighting, so there is, but I'm not gonna help. Already, RTX gives you a chance to implement a very complicated API, and you know, at the end of the day, it's ray tracing. It's not anything like it might be. It's probably a bit faster than if you did it in compute and whatever, but it's still not proper lighting, right? You still got to fake stuff if you want it to run more than 2 frames a second. Right, here we go. Oh, that's orientated, I can tell you that. But. Oh, it's in local space. That's why the border was so damn big. So if I just did like, oh, 0.05 border. Is that big enough? Holy, no. Border thickness in local space, number 13. Yeah, we're barely hitting performance targets at 1 SPP. What's an SPP? And that's at a lower render scale. Yeah. Yeah, well, wait, we're talking about my performance. 2 milliseconds, that's right, isn't it? I was talking about the, we're gonna use ray tracing. Yeah, yeah. RTX and all that. Sample per pixel, I see. Yeah. If you use like 1 sample per pixel, and then they'll do like a downscale thing, you get it to upscale, yeah. It does, it's really expensive ray tracing. Like, when you have a big scene, you've gotta, yeah. That's why I'm hoping if we're doing a custom acceleration structures and stuff, the primary rays should be kind of cheap. I don't know, I've got to compare it. Because I'm doing a tiled binning approach for the primary rays. I hope it'll be alright. The secondary rays, though, they're going to use the BVH. We'll do the industry thing, BVH. I think we did some calculations. Primary rays should be faster if we bin the spheres. Just gotta be careful on the number of spheres I put on the screen at once. And that's why I've got to have a good occlusions buffer, which is more calculations. But yeah. Ray tracing is cool though, right? If you do like a forward renderer and you ray trace, you gotta do it all in one go though. But you can get some good anti-aliasing and transparency. And some good effects as well. But it'd be a very complicated shader. Be a lot of VGPRs. all over the place. Boolean subtractions, they're SDFs, my friend. Thirteen. Wait, you're talking about I've done a Boolean subtraction. So, what am I doing wrong? Oh, that's a bits from, not bits to. So implicit casting in C completely bugged me up. Okay, but my eyes didn't fail me. Oh yeah. Okay, so we've got the orientated box. It seems to be working. Amazing, but we can't, be like, oh, this is great and everything just yet, because there's one more thing. What happens if the sizing, like, I think I just multiplied it by 1. And my view normal's a bit wrong as well. I've got to translate that back. Let me do that quick. The head depth is fine because the length of the ray could change. The length of the ray could change. Actually, so mol v transform. I think I'll do that trick, right? View from local, and we'll splat that. I think that'll probably be alright. Now, the normal. Just want to do that. So the problem is we'll be in local space at that point. Alright. So let's try that out quick before I change something else. So this is still looking alright. Ignore the glitches. This is what we've got to fix. This is why we're doing doing what we're doing here. Why we're doing debug draws. So the thing I want to test out now is what happens if I make a smaller cluster of spheres. So let's find that OBB code. So I think this thing is hard coded to. Yeah, so one shift left. Okay, so that'd be 0 plus 1. One shift left 1. 1. That would be 1, right? So what happens if I hard code this to 0.5? Does the thing work? Right, so this is apparently smaller. And it seems to work, right? So let's change this to 0.25. And then what we're gonna do is we're gonna make the bot. I think what we'll do actually. Okay, the spheres got bigger, and they're only bigger. Yeah, I think that went the right anymore. Did that just go the wrong way around? Well, whatever it is consistent, right? The cluster grows to the same shape as the debug thing. So I think that's good. That's a good tick there, and I think that's good. So what I want to do, what I want to do, is make a nice handy dandy function for this, because this is going to be another great thing, right? So in local space, so what you want is an O where you define. So we need two versions. We probably need two versions of this one as well. Yeah, one chip cut, another one. Oh, okay, yeah, like a sun distance field. Yeah. The other way. SDF's a great man. So we want another one. No, we don't have overloads, obviously. So we've got to figure out a good name. This would be like a half dims in local space. Lovely long name, so. So AABB. Maybe I should call this one view from space rather than local, but whatever. ABB. I want to have one where we can define, what was it again? It is more of like a min-max. So this is going to be like a... we'll call it min-max. That's fine. So these ones actually should probably be they could be defined in one place, probably. Probably in the shared code itself. It could probably define right here. I'll just define them twice. Screw it. Alright. So this one is going to be called OBB. So you draw an OBB. So this one is kind of like normalized, whereas this one is not. And I think that will mean, yeah, I like that. So let's plop these in here. So this one is going to call this one up here. This one's going to be called norm now. This one is going to... oh. So essentially, right, you want to produce the half size, which is probably a max take min, then multiplied by 0.5f. Oh, it's got to be an S, moles. Then this would be a yeah. Just be an add. Float 32 times 3 from min, half, and done. So there we go. There's that helper function. We'll copy paste that. Then this one is going to take that lovely code here, which sort of scales the transform local space by that sort of like half dims thing, right? So .x, y, and z. Oh yeah. Then we want to call that norm version. So that's only for normalized ones. Oh yeah, then you gotta pass another color and all that jazz. Border thickness and local space color, and then z test. The splat of ray distance for computed depth looks suspicious to me. How is that supposed to work? For computing depth? Oh shoot, where's that? The ray distance. Ray distance. There's my shader somewhere in it. Do you remember where that was at all? What sort of shader was it in? Was it in the debug render? Ray tracer, or was it a different one? Line 3? Oh. No, it's a relative line. Right, okay. There. Right, thank you. I know where I was in. I know where I was at. There we go. That's where I was. That's suspicious to you. Okay, excellent. Excellent. So that depth is the ray. Right, let me explain. I need your help. So effectively, we've got this ray. We've transformed the ray origin into local space from view space. And so that's probably, if you've got some non-uniform scaling, it's going to mess something up, right? So then when I get the hit back, I want to translate that t. So x is the t, you know, the scalar to travel along the ray until you hit the bounding box. So I want to kind of like bring that back into like view space, right? So how do you sort of do that when you've got a scalar value? You can't take a single dimension, you've got to try all the dimensions. So I splat it and then oh, you're saying convert it into a vector of hit position and then retake the length again. That is good. Yes. That is the way. I can see it now. I can see it. So what you're saying is ray direction local space. Compute that. There's the hit position. So that will then be the hit position in, and then you want to do a subtraction going towards the hit position From ray origin local space. Ray origin local space towards the hit gets you the new vector length of that. Boom. Legit. Thank you. Thank you, thank you, thank you. Should be alright. Let's bring this into the GPU version. We've got GPU version as well. Rightio, so now we can try that out. What I want to do, so I can just call this version where I pass in the half extent. Oh yeah, I don't think I applied the translation. I think I did a mulvi. Yeah, I did a mulvi. We'll double check that in 1 sec. There. Yeah, do a mulvi, so just the vector. Yeah, no positional, translational stuff. Rightio. Looking good. Look at that. Orientate bounding box. We've got vectors, got bounding boxes, and we've got spheres as well, but these are not debug spheres. These are the different spheres, but we do have debug spheres as well. I have ray origin in the expression because I want to take so this is, let me take this out and make it more readable. This is, oh wait, that's in local space. Ain't good. Hit position in view space. Yeah, so get the hit position in view space, we draw a vector towards that from the ray origin, then we length that, right? Because the ray origin, wait, the ray origin is at 0, 0, isn't it? I'm blown. Because it's in view space. That doesn't really need to exist. But yeah, I'll put it in there for explicitness, but it should get optimized out. Just in case the code ever gets moved anywhere else. That's a good point. Compiler should catch that. Yeah, so... Right, so I'm glad we got that. We didn't try... Was it doing a discard? Oh no, it's not. Good, 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 good. So let's try the depth. Make sure the depth is right. So if we put true on there, that's going to do a Z test. Oh yeah, look at that. You can't see the background of those on that box, can you? That's good. Oh yeah. Look at that. Good. Obviously got some glitches, we're going to fix those soon. Alright, so let's give a bit of a recap. What we've got now is all of these guys working. And I'm pretty sure they all go because we've done some testing as well. So we draw bounding boxes, we did min-max bounding box, orientate bounding box, spheres in view space and world space. If you want anything else, you translate it there yourself. But I doubt we'll need anything else. Maybe we can offer a transform version. Yeah, but... And then we've got the vector as well. Just manually transform yourself maybe. But maybe again, if I can see it being a bit too fiddly, maybe I'll just do a transform version as well. That ultimately just makes the view space version under the hood. So that's the 3D stuff done. These are going to be super helpful. They can be called from CPU and GPU. And I think we're doing how many are we doing? What is that? All right. So for 3 shapes, it's costing 0.4 ms. We've not optimized this in any way. We're just doing every pixel's going over every single shape. So in future, if that needs to get better, we will do a tiled renderer, but I just wanted to get it working as quick as possible. So we support up to this many words in a buffer, and we, so the more stuff that gets encoded in the buffer, some shapes have different parameter, different number of words, which you can tell if you just go to the implementation. So you got like 9 here. This one takes up 9 words to cram all these in, and we just read them out for every pixel. Read them out and operate on them. So in the next stream, I want to get this draw 2D sorted out. We're only doing axis line, bounding box, circle, and vector. These will be enough for what we need, I think. This one is going to help us actually find the bug that's making those spheres blink everywhere, because our screen axis line bounding box, which you can't see right now, is causing that to sort of flicker, because it's just not right. It's not calculated correct. Yes. Then after that, next stream, I'm sure we can get this done quite simply. Actually, it's just another shader with some SDFs. We'll be debugging that screen space problem and trying to get LOD 0 working perfectly, and then do LOD 1. And after we've got 2 LEDs working, the rest should just work. But we're gonna see, right? Man, that's awesome. Happy about that. So I'll commit this up. Yep. So we'll commit this. Yeah, so add or get draw 3D API working on CPU and GPU. Nice. So I'll put that up on the repo for those guys who are supporting the stream. If you're a Twitch sub or a Ko-Fi supporter, you'd be able to get access to that and have a play of it on your machine. The Windows build is currently broken. That will get fixed at some point. I've just not had the time. But we've been doing a lot of behind the scenes programming with this LOD system. So I've only just got stuff rendering again, to be honest. So yeah, I need to get that sorted out. Right. I don't think you should use the origin at all, since we're dealing with vectors and not. Are we dealing with a vector? Because that's the point. Point take point equal vector, right? Oh, yeah. Sorry, I see what you're saying. This is a vector. Oh, crap. I see what you're saying now. Yeah. So that's already transformed. I see. That's like a hit. Um, Rate to hit position in view space. Yep. That's more correct, isn't it? Thank you. Okay. Wait. Gotta test the code. No, it still works. Thank you. Git commit dash a. Fix. Fix maths. Thanks, Russ. Must go. Let's go. There we go. Right, so the next stream will be Sunday at 6:30 p.m. GMT +1. Wait, when did these time zones change? Did it change already? I don't even know. When's the weekend? Last Sunday in March. Damn it, it's a time zone change. Alright, I'll be on at 6:30 p.m. GMT +1. Because it goes from GMT to GMT +1. But yeah, I guess there's a Twitch timeline or whatever, but I also post in Discord when I'm live. There is that one too. Yeah, Sunday. Easter Sunday, let's do it. See you all you guys then. Let's find somebody to raid. Thank you for coming. Very successful stream. Sure. Trade the Jai guy. Rightio. Have a good Easter Friday, Saturday, and Sunday. I'll see you all Sunday. And yeah, thank you all for coming. Down toast, thank you, sir. Good night. Right. Good night, guys.